Alright everyone, I'm Shaurya and this will be the solution video of problem 2 from the TCP Open Contest 1. I hope you enjoyed the contest as well as the problem. So let's jump directly into the solution. The problem is searching for food in trash, right? So Dr. Drunkenstein, while scavenging for food in the trash, stumbled upon an ancient scroll with a strange encrypted message. The message consists of a long string of letters and he suspects that the word food is hidden inside, but the O's can appear in any number as long as they are contiguous. Okay. Your task is to find and count all the occurrences of the pattern such that it starts with F, followed by one or more contiguous O's, and ends with D. Right? The input format is a single string S containing the lowercase English letters. Right? The constraints of string S can go up to 1 is 6. The length of string can go up to 1 is 6. In output, we have to print a single integer that represents the pattern, like food, right? And the F, then contiguous O's, then D. Okay. So let's see the sample input. Here we can clearly see first food is here, then food is here, then food is here. In this we are not counting it as food because why? Because F, then no O, and then D, right? And again here F, then contiguous O's, but no D, right? So if D was there, then we might have counted it, but D is not there, so we have not counted it. So here you can see the explanation: food, food, and food. Okay, so the solution is very simple of this. It is basically an implementation based question. So in this, what we have to do, we have to just to be honest make a finite automata, right? For if we see F, we move. Then if we see O, then we will stay here until unless we see a D, right? Like let me redraw it once. So if we see and F, we move. If we see O, we stay in here until we see O's, and then after if we see D, we will reach our final state, right? So that is the solution of this problem. The main solution is the coding part, right? So let's see how we will implement it. So what I'm doing, I'm taking the input. Here you can see the input file. Then I'm initializing my count as 0 and n is the size of the input. Then I'm taking one by one each character. If the character starts with an F, then what do? I initialize a pointer J. J is the next character to F, right? So let's say the input was F O D, right? So my I was here. And then if I scan the F, then I initialize a new variable J, that is I plus 1. Okay. Now, if S of J is not equal to O, if it is not O, then what we do? We continue. We skip it, right? We will check the next character, right? Why? Because we don't want FD or any other thing. We want F, then O, right? So we will move. Next, while J is less than N and S of J is O, we just simply move our J pointer. And at the end, what we are doing, if J is less than N and S of J is D, then we increase our count by 1. And in the end, we are printing our count as answer. So let's do a quick dry run of this, then you will understand it easily. Let me just write down the input. The given input is F O D, then food, then F O D, then D O, F O D, F T F F, D O F O. Okay, I have like D O F O. Okay. So first my pointer was here, I scanned an F. Then I initialize a pointer J here. Okay. Now what I will do, I will simply just move my pointer j here, then here. Why I will move? Since j was pointing to O, and then while j was pointing to O, I have moved it, and after that j will move here. At this point, this while loop will break, right? At this point, this while loop shall break. Why it shall break? Because this while loop. Because at this point j is not pointing to O. Okay. So now we can see our j is now pointing to a D. So if j is pointing to D, if j is less than n and j is pointing to a D, then we will increase our count. So at this point we will increase our count by 1. Okay. Then we can do a subtle optimization here. After this if loop ends, we can just put I is equals to j, right? But because here now again I will start from here, right? So we can do a subtle optimization here. So you can do in your code put a I equals to j here. So after that I will point here. Let me move the I here, and also let me raise this I. Okay. Now it is again, now I is D, so nothing will happen. I will move forward. I will move forward, and again the I is pointing to an F. So again it will form a variable, new variable j, right? So again a j will be formed, that is I plus 1. And again it will see contiguous O's, move, and then D. So at this point it is not seeing a contiguous O, so it will break out of the while loop. After that it checked that it is a D, so yeah, it was a D. So again the count will increase, right? So again the I will point over here, and j was here. Let me just shrink it down a bit. Okay. Yeah. Now again what we are doing, I and j was pointing over here. Now again I will move. Is it a F? No. Is it a F? No. Is it a F? No. Is it a F? Yes. If it is a F, yes, then we will initialize the pointer j, that is I plus 1. Is it a O? Yes. Is it a O? No. Break out of the while loop. Then is it a D? Yes, it is a D. Increase count. So our count will increase, right? Then again I will move over here. It is a F? No. I will move over here. Is it a F? Yes, it is a F. Then it will create a j, that is I plus 1. Is it a O? No. So if j was not an O, so you can see clearly over here, if j was not a O, we will continue. What will continue? We will move the I, right? So if it was not a O, we will move the I. So again this I pointer move over here. Is it a F? No. Is it a F? Yes. Creates a j pointer. Is it a O? No. Move the I. Is it a F? Yes. Create a j pointer. Oops. Is it a F? Is it a O? No, it is not. So again move the I pointer. Is it a F? No. Is it a F? No. Is it a F? No. Is it a F? Yes. So in last what we are having F O O O. So our I is currently over here, j is currently over here. So is it a F? Yes. Create a j, I plus 1. Is it a O? Yes. Is it a O? Yes. Is it a O? Yes. Is it a O? So it will move out of the bound, right? So as you can see here, no occurrence was D there. D was not present. Hence the count will not increase. Count will not increase. Hence the answer will be 3. Okay, it was a purely implementation based question. There was nothing to think a lot of it. It was just a simple this. Okay. Thank you.